Standards document that is attached in the course specification for National 5 and higher. It's really important that you're referring to this document on quite a frequent basis. Remember, if it's not in the course specification, it is not required for study at that level. So this video will point out the differences between the National 5 and the Highers. Also, please use the Quizlet. It's important that you get these spot on. The standards and conventions are the rules which will dictate all of your technical drawing. The lines in particular are really important that we differentiate at National 5 when we're doing our manual sketch orthographics, and at Higher when we set our line weights on our CAD drawings. So when we start out with a drawing, just going to trace through a very light orthographic that I have on the previous page. This is the orthographic in reverse from the introduction to orthographics. So I have used very light lines. These can be used for construction or for projection. So what I'm doing just now is I'm projecting out the drawing. So this is described as a continuous thin line, and it's used for projecting between drawings, or it's used for constructing drawings, or you'll also see that it's used for dimensioning later on. So line type number 1, continuous thin projection line. Line number 2 that we need to know about is when we are finished with our drawing and we want to identify visible edges. These visible edges or outlines are a continuous thick line. Remember, when we are constructing our drawings, we would already have the projection or construction there, which allows us to create these nice sharp corners for the visible edges. So these are edges that if we were looking at the object, we would be able to press and define as being real. So line number 2, continuous thick for outline solids. When we are doing our orthographics, remember, if we're looking at something through, so i.e. this end elevation, we cannot see this edge, but it exists, and therefore we would define that as a hidden detail, and that is done as a dashed thin line. Remember that the edges must meet the outline, and then a continuation of even dashes. Okay. Once we have got that hidden detail lined in, it therefore makes our drawing make much more sense. So, next thing that we had on this previous drawing, the one from the last, was we had our plan where we had added a circular hole at the top. So projecting that up again, so just making sure that I'm happy with everything, and then again I would outline. When you're outlining, it's best to reveal the drawing so that you're not smudging if you're using a darker pencil. Okay. And again, so we've done continuous thin, continuous thick, dashed thin, and the next one is the centre line. So if we have, and I'm going to very carefully sketch in our circle. If we have this circle, we need to define the centre of it. Now, when you were doing drawings using the drawing board, you would actually mark out the centre first. You would then apply the point of your compass to the centre point and then scribe your circle. But because we're doing this as a sketch, we can kind of find out where the centre of our circle would be. So centre lines are now long dot, okay, long dot, so it's defined as a chain. However, previously you may see drawings where it's long and the dot is actually a dash, so it's long, dash, long. Both are acceptable, but really what we're looking for just now is a long, dot, long. Remember, we talked about this in the introduction to orthographics, that the long line should break the circle and extend beyond it. This helps identify where the largest part of the circle is, as well as reinforcing the idea that this is an imaginary line. So if I was looking at this object, I wouldn't see the centre lines. This is purely for measurements, for dimensioning. I wanted to dimension to the centre of the circle, which is more common than to the edge, because it's a bit more difficult to get accurate. These centre lines allow me to apply those dimensioning. So just to make sure that my drawing is correct, I will extend the hidden detail down. So with centre lines, the long dot, long dot, long, when there's a circle, they have to cross in the centre. But if they are being looked at in elevation, i.e. like this part here, to make it look like it's not a rectangle, we apply a centre line down the middle. It's the sort of centre axis. So if we were on Inventor, this would be your axis of revolution, and that allows me to identify that this is a cylindrical hole, not a rectangular one. Remember, all three of our orthographic views must match, so just filling in the hidden detail here. Okay, so those are the line types that we have covered so far. For National 5, we will still cover the next line, but we haven't covered this topic yet, so it might be a bit more confusing, but for higher this should be revision. And that is going to be the idea of the cutting plane. So this object here just now, I'm not really going to get that much more information drawing the end elevation like I had done on my previous page, okay? So what I sometimes do, in addition to having my plan, my elevation, and my end elevation, is I will have what is called a sectional view. And to help me out with that, I have got a tiny wee object here. Now this is a little rubber capping, so I'm just going to hold it up just so you can see how terrible my nails are, but also you can get the idea that inside this is hollow, but from the elevation it's not really that obvious, okay? So I'm going to flip it around till the focus comes back in. So what might help is if I was to create a cut and section this, okay? Now I could create a cut through any point of this rubber cap. I could cut it through this way, to this way. If I really wanted to, I could cut it through that way. And depending where the view goes, I could create a sectional plan, a sectional elevation, or in this case, a sectional end elevation. So all I do is I have to specify where I am creating that cut, where I am going to chop through the object, remove part of it, like that, and then I draw my sectional end elevation at what is remaining, okay? And being able to do that, what it allows me to do is see straight in. It's much easier to understand than hidden detail. So to indicate where I'm cutting it, I have to create a new line which is called a cutting plane. Planes we will cover when we're doing Inventor. Plane is just a flat surface. So where am I going to cut through? I'm going to cut through here, here, here. So in this case it would probably make much more sense to cut through the hole. So I could cut through the hole at any point. Generally you'd cut in half, or you cut through the centre line here. But what I'm going to do, just to make this a bit more obvious, is I'm going to create my section line or cutting plane here. The section line or the cutting plane is just like a centre line in that it is long, short, long, dot, long, dot, long. But in order to differentiate it from the centre line, we make the edges of here thicker. Now when you get to higher, we will encounter a type of section called a stepped section, and a stepped section means that we are going to change direction for our cut, and what we'll do is anytime we change direction we thicken the corners out of our cutting plane. Okay, then we have to illustrate what part of our material is being removed and what is remaining. So I'm going to be taking this small section away, it's going to disappear, and I'm going to be looking at the remaining object from this view. I then create two arrows. Remember, all arrowheads should be small, black, and filled in. Small black arrowhead. And it points to the direction I'm viewing in, it points to the amount that's remaining. We then label it starting from letters A. If you have a series of drawings, you would go section AA, BB, CC, and so on and so forth. So what am I doing? This bit doesn't exist. My drawing starts here, so I project it over. This is not a video on how to do sections. There will be one of them when we come to that topic. For higher guys, this should be revision regardless. And then we fill it on. There is no hidden detail in a section, because instead what we have now is we have hatching lines, which are also continuous thin. you can use the continuous in for your hatching lines. And the best way to think about it is if I had been in the workshop, I had put this object through a bandsaw, where would the saw marks be left? Now the saw marks can't touch this part here because this is my saw blade, so this bit does not have hatching. This object has gone through the saw, so I then have a series of 45-degree lines which will change depending on which component I'm doing. Now this is all one part, so therefore all the hatching will be continuous in the same direction, always at 45. As I said, not a video on section rules here just now, just an illustration. The labelling for this is sectional, end elevation, A. Okay, it's really important that remember the view names always go underneath, it's another convention, and we always use the labels that we've done here. Okay, so we've done outside outlines, projection lines, hidden detail, and centre lines. We've also introduced the idea of the cutting plane, which is necessary for National 5, and the last line type that we need to know involves this. Okay, this is called a development. We will be covering them at National 5 and visiting them at higher. So this is going to create my shape. When it is folded out, I need these fold lines. If I was sketching this, I can't use the outline because the outline would be for the visible edge. It's not technically hidden detail because I can see it. It's obviously not a centre line. So we need to create a new line for folds. And the fold line is long up the edges where it overlaps, but this time it is a double dot and then long, double dot, long. Okay, so the fold line is long, double dot, long, double dot, long, double dot, and that represents the fold. Okay, for higher, the other thing that you'll need to know about just now, and I'm going to show this guy again and just get up, is this. This is knurling. So when you're doing metal work, it is possible to use the lathe to apply a texture to an object, which gives it better grip. And if you look at the technical graphics building specification, or the course specification rather, you get two types of knurling. This one here is obviously been applied in a sort of diamond pattern, and it would be represented with diamond lines. If this was just a straight knurling, it would just be a series of straight lines. The other thing I wanted to introduce just at this video, even though it was in the building symbols, is the third angle projection symbol. So when I did the orthographic over here, I had a really bad third angle projection symbol. This is the representation. This is what the third angle represents. Okay, this is what the symbol is. It's a cone which has had its top chopped off. When we are looking at it in elevation, we can see the smaller circle here. That's that top circle. And then we have the bottom circle, which is here. Okay. To prove that this is obviously a circle, just to reinforce it, we add the line type we've just learned about, which is long cross, line, line. Okay, so that's the circle there. So that is essentially the cone in elevation. When we are looking at it from the right, we would then see this shape, and I'm just going to flatten it down. So you've got this four-sided shape, and this line here, the front line, is the same size as that circle, because remember when we turn it round, that's what it's representing. So this, coming out, we project it across, would be the start of your third angle projection. And this larger line at the back is the same size as this circle here. And then because remember we know that this is a cylinder, we can then continue that centre line all the way through. So when you're looking at the third angle projection symbol, this is what it's representing. It's looking at it from elevation and end elevation. If it was in first angle, this view appears on this side, and it doesn't make sense when we've been operating in third angle. So it's just a wee reminder that we have a cone, and our two views.